So before going to the file operations, I will just give an overview regarding the file system in Linux operating system. Okay. So how the files are arranged, what kinds of files are available. After completing this, it will take nearly 1 week to complete the entire file operations. So first I will start the theoretical part now, then we will complete one by one. So coming to the point of file system. So can anyone say why we need file and what is the need of file? Why the name file system? The name file system. Can anyone say what is the need of that? Why it is needed? Can anyone say? Okay, I will itself say no issues.
So
See
to
here.
store and
There will be
manipulate data
parent and child
whatever
relation,
and
madam.
Yeah, to store the data, yes, to segregate. So to store the data, to arrange it organizedly, to organize the data, to organize the files. So we are having one system. Okay. See, suppose if, for example, how you will be arranging. Suppose if you're having one files regarding your operating system, regarding your mechatronics, regarding your economics, so you will be having separate folders. So regarding that assignment, something. So to organize your data, and for easy access and for saving a memory space. So we are having one system that is here. I'm organizing my files, everything in a arranged manner, that is I'm saving my space for easy access, and I'm saving everything, my private files in confidential manner. So I am using this file system concept. So not only us, every operating system, all of us are using this file system concept. That is the major aim is to organize the files and folders. Okay, to organize the files and folders to save the memory space, and to delete unwanted files. These are the some basic needs while we are going for file system. So coming to the point here, see the same story here I have given again. The file system. Mm. So the file system is a process that manages, okay, that. So the file system is process that manages how and where to save a data on a storage disk, typically a hard disk drive, and where here the data is stored, accessed, and managed. It is a logical disk component that manages a disk's internal operation as it is related to computer and it is abstract to human user. So nothing but, so here what we are trying to say is, here it manages where we have to store the data, where we have to access the data. So here I'm saving all my data are saved in the storage disk, that is nothing but your hard disk. Okay, in your system you're having partitions like CDE. So that your all your files are stored, and it is accessed and it is managed. It is logical disk component that manages a disk's internal operations. Yes, it is a storage space. It is a logical component only. No, you are unable to view. So it is a logical component where all your internal operations are being done, and it is related to a computer and it is abstract to the human user. Is it okay now? So your file system provides a way of separating a data on the drive into individual pieces, that is called files. It also provides a way to store data above these files. Here files, one second. Okay, fine. Here the file system, it provides a way. So how to separate the data, how to save a data. You will be saving data based on your requirements like DS folder, like DS600, module 1, module 2, module 3, big data or Python. So you will be saving separately, right? Why? Because for easy access, and for that is what they are given for storage purpose, for easy access and to manage. So a file system provides a way of separating a data on the drive. Yes, you are having separate drives, right? So how I am separating based on my requirements, I am separating into individual pieces, that is called files. It provides a way to store data about these files. Next line. So here your operating system needs to understand the file system so that it can display its content. It can open the files and it can save the files to it. If your operating system doesn't understand the file system, you may able to install a file system driver. You have to install the file system driver that provides a support, or you cannot use that file system without that operating system. Suppose if any of the operating system we are using, so the particular operating system should understand what is happening. Why? Because yesterday in day one class itself, we have discussed operating system is responsible for memory management, right? Memory management and process management. So here memory management means mainly it depends upon storage. That is storage of files, storage of folders, how efficiently you are using that memory. Process means what are the tasks you are doing. Here I'm opening the PPT, I'm downloading something, I'm downloading games, and I'm chatting something. So each one is one of the process. So only the word they are given, your operating system must understand what is happening inside the system, how the user is interacting with that. If it is okay, everything is okay, or not, or else you have to install that file system particular driver, then you have to work on it. Is it okay now? This is what normally we are happening. All right. I will see here some examples here I have given. So metaphor here is paper filling system. Here the bits of data on a computer are called files, and they are organized in the file system. The way the paper files might be organized in file cabinets. There are different ways for organizing these files and storing about them, that is called as file systems. Normally, in offices, in libraries, you used to see how the files or how the books are arranged. They are arranged separately based on the names. This is Python, this is R, this is something, machine learning. So here also, that is what they are giving. They are organized in the file cabinets. The same way in that is here in physical mode, they are organizing in file cabinets. In digital mode, they are organizing in the file system. The main aim is our memory management or easy access, deleting unwanted things, and we have to use the space and the process efficiently. So that is what we need file system. See here, some extension they are given. Uh, FAT32 is an older Windows file system. This is one of the file system that Windows is using in earlier times. Okay, one thing I like to say here, swap no, swap. What is the file system here I'm using? Swap file system. See, go to the, see, wait, I will share my uh, terminal. Now, VD. Hmm. See, now I'm moving to this root page. Okay, now I'm in root page. See that symbol, that forward slash is there. Now, what I'm trying to do, I'm trying to list out ls. See, one swap file will be there here. This is what here. Is it okay now? What I'm saying here, one swap file is there. No, this swap file is nothing but your common file system that Windows operating system is, sorry, Linux operating system is using. That is what I discussed now in theoretical part. Is it okay now? Wait, I will share that PPT also. I am unable to switch many screens. I'm getting confused. One second, please. Now it is visible. Ah, now this is what now I showed you. Is it okay now? Where it is available? It is available in root folder. I think now it is clear. It is okay now. This swap file system is organizing the entire file management here, accessing your files, accessing your folders efficiently. Is it okay? Like that, this BTRFS is one of the better file system. Like that, extension 2, extension 3, extension 4, these are also some of the common file system that we are using in Linux. Okay, in here, NTFS we are using in one of the versions of Windows. These are the some common file systems that we are using in operating systems. Now, is it clear now? So, coming to the exam point of view, in this case, they will be asking which operating system is using which file system. Here, since we are for us Linux is the base, you will be getting a question as swap is a file system. So, which is the file system that your Linux operating system is using means swap file system. Is it okay now? Okay, next coming to the next one. So, okay, now our file system, what we are using is swap file. Here, mm, three basic type files is there. Normally, ordinary files. Another one is a directories. Another one is special files. Am I right? Ordinary file is normal ordinary file what we are working on it. It may be a notepad, it may be any document, or it may be any Excel sheet. Ordinary file, ordinary file is a file on the system that consists of your data, text, or program instructions. Is it okay? Directories means folders. Directories store both special files and directory files. Am I correct now? Here, in case of special, coming to the point of directories, in directories we may save special files, or we may save ordinary files. Am I right? Ordinary file means some what file we are using. Here, special file means that are the files like system files, right? System files, then your library files. No, we are saving in that will be coming in the special files. See here, special files. Some special files provide access to hardware churches, hardware drives, CD-ROM drives, modems, Ethernet adapters. Other files are similar to aliases or shortcuts that enable you to access single file using different names. This is what I have showed you in the morning. See, now I'm moving to my terminal now. My VDA lab, I think my VDA lab is enabled. Now I'm in root mode only. See, these are the, I have highlighted no. These are that special files and special folders. That bin, boot, CD-ROM, device drive, etc. Home page. Now, okay, na? These are exactly your special files. Where it is located in root mode. Okay. Okay, next. So coming to the point of Linux file system. So Linux file system is a logical method of organizing and storing a large amount of information in a way that makes it easy to manage. As we discussed earlier, that is why file system, why we are going for file system. Here I'm organizing my content, here I'm organizing my data. Here I'm organizing all my information as a data in a single file. Okay, what are the information I'm having? Here I'm having student information, I may having exam information, anything, all kinds of information I'm putting and I'm saving in my some space, some file. So I'm organizing, that is why I'm arranging for easy access. So it's a logical method of organizing and storing large amount of information in a way that is easy to manage. Is it okay now? So second point, a file is nothing but a container in a computer system which is used for storing information, like container normal like basket something, no, something it is used to put something, some objects. The same case here I'm having folder. Okay, here I'm having some separate folders, module 1, module 2, module 3. All these folders where it is available, it is available in that particular file system. Okay, so it's just like a container where I'm saving all my information. So third point, Linux file system has several important features. All data in Linux is organized into files. All files are organized into directories. These directories are organized into, this is major point, these directories are organized into tree-like structure, and this structure is called file system. So in Linux, coming to the point of Linux, how they are organizing. Here all the data in Linux are organized into files. Datas are organized into file. Yes, I'm having student data. Suppose for example I'm having information about all student information. I'm having information that is DS600. So all the information is converted into some file. That files where I'm organizing that files into, see, information I'm storing in files. That files I'm organizing to directories. Okay, these directories are arranged in what format? Tree like format. Information, all information I'm storing in files. These files are stored in directories. These directories are arranged in tree like manner. Is it okay now? One important system, one important point here you should remember is what is the file structure the Linux is following. That is tree like structure. That is topmost, top to bottom. That is from hierarchical manner, parent to child. Is it okay now? Okay, ma. So I'm moving to next one. See, files in Linux systems are organized in, Files in Linux systems are organized in multi-level, that is multi-level hierarchy structure, which is known as directory tree. How it is organized? So it is organized in multi-level hierarchy structure. That is, suppose if I'm having A, it will be having child as B and C. So again, it will be having a child as D and E. So multi-level hierarchy structures. Based on that, it has been arranged. Okay, one is, that is the topmost is we are having as a parent one, or we can say as a root node. See, at the very top of the file system, there is one directory. That directory we are calling as root. Okay, that is the root one, or that is the admin one, we can say that is the topmost priority. So we are calling that root as representing by using forward slash symbol. That is, we are representing by using forward slash symbol. Other files, that is apart from root, all the other files are descendants of roots. So descendants means, what is the meaning? They are hierarchy. Okay, here that is, here root is a parent, remaining all the folders. It may be your special files or it may be your ordinary files. Everything is a descendants. That is, it is a child one. Okay, child, child, child. Descendants means what, you understand the meaning? No, generations. The same case here, your root is, that is forward slash is a root one. Remaining all the folders are is a descendants of root. That is, root is a parent one, parent directory, and remaining all the directories are child directories, subdirectories. It's keep on going. Okay. So coming to the point, in the slide you have to remember only two points. That is, first one is, you are calling is the root node is a top priority mode, and the root node we are indicating by using forward slash symbols. See here, this is the structure. This is what the exact file system of this is what exact Linux file system what we are using, because this is one, that this is what we are representing as a root node. Okay, this is a root node. The topmost priority here we are given. Okay, or we can say here root node I am indicating, it is indicated by using forward slash. So this is a parent directory. So as a root node, all the important special files and special folders are available. That is bin, your device drivers, your etc. files, your home page, your library files, your mounting devices, procedure files, root files, sbin files, temporary files, and user files. These are the files that is these are the major files or special files that is available in root node. Okay, each file has some special functions. See here, bin file, bin, most of the installation everything will be in bin. DEV is nothing but your device drivers, extra devices. Suppose if I'm inserting hardware, I'm connecting hard disk, or suppose I'm connecting any Ethernet adapters, or I'm connecting pen drives. So all kinds of device driver files, that is codings, are written in device. That all the files are available in device drivers, etc. This is what I have discussed in first day itself. That is password, that is protection related, all the information files will be available in etc mode. Okay, na, the like kinds of authentication, what are the password I'm using, it may be your admin password, any kind of password. That password related files will be available in ECT. That is, it will be available in shadow. That is home page. Home page is nothing but your parent directory, where we are working on it. Here in home page, I'm having Nilite as one of the user. I'm having student at one of the user. Inside that, I'm having my profiles. Sorry, I'm having some my own files and folders. Okay. Next one, your library files. So library files means is as usual some special kind of files only, which is used for accessing. Next one, mounting files. M and T is nothing but your mounting files. This mounting files and device driver files are more or less similar to each other. That is, what are the devices I am connecting, what are the devices I am mounting on this particular device. So that related information or that related files are available in this two special folders. One is the device driver folder, another one is mounting device folder. Next file, that is next special folder, is procedure folder. So what are the things? This is also one kind of special folder only. Okay. Next one is a root user, root folder. Next one is sbin folder. Next one temporary files. Next one, user. Wait, I will go inside. I will move to next slide. See, Linux file system is a collection of files and directories which has the following properties. It has a root directory. That root directory here we are indicating by using forward slash symbol. Okay, that contains all the other files and directories. Each file or each directory is uniquely identified by its name and the directory in which it resides and the unique identifier typically called inode. So, suppose here no in Linux operating system, suppose here I am creating one new directory. I am creating one new directory called DS600. Okay, DS600 immediately and one unique number will be created for this. How each people is having an unique Aadhaar number, right? Suppose if I am giving a unique Aadhaar number, the entire information will be we can retrieve about that particular person. The same case here also the same case for each directories or each file whatever I'm creating, the kernel by internally by itself it will assign a unique number. That unique number we are calling as inode number. Okay, this inode number we will be indicating as I. Okay, why this inode number we are using? Can anyone say? Suppose in my Linux system I'm having thousands of folder, right? How why can anyone say what is the need of inode number, or what is see coming to the point, what is the need of Aadhaar number? To identify case, right? Who is identifying? Some suppose if you want to access, if you want to apply for any exams or um any information you want, right? In that case Aadhaar number. In the same case here no, each file or each whatever directories we are creating, here immediately the kernel by itself, right, it will create an one number, that is unique number. Okay, this is for kernel identification. Okay, suppose if I want to access, see here I'm giving one file called, suppose I'm giving one file name sample.txt. Immediately what it will do, it will it will search for that particular inode number. Like book no, in that book I'm having, how we will be searching in that index page or by using page number. The same case here the kernel will identify that. Okay, kernel will identify that particular file and folder by using inode number. Okay, my question is, as a user, we can access inode number or not? My question is, here we are user, right? Can we access this inode number to search a file? My question is, I want to search one file. That particular file name is sample. My question is, how as a user, how you can access that particular file? How you will access? My question is, how you can access, or as a user you can access inode number or not? Here user will access by using file name. Am I right? How you will be access? You will be giving that file name vi space file name dot txt. Internally kernel will access by using inode number. As a user we are unable to access that inode number. Okay, the kernel will identify that inode number. How we user access it by using file name. The kernel will access by using inode number. Now is it clear now? Here I am giving, see here I am giving vi space file name dot txt. Here my file name is sample. Immediately no, suppose it is a new file. One second ma, I will move to that editor. See, is my terminal is visible? One second, I will, no, it is not visible. Yes, one second. I think now it is visible. See, ls I'm having one file, I'm having, okay, one file I'm having sample.txt. So ls minus li I'm giving. See how I am giving. So here the sample, this is ls minus li. So ls minus li means it indicates the inode number. Also it indicates which file is recently modified, that will be indicating at the top. Suppose if I am giving sample.txt, okay, I am giving here as a user, I am giving, I know only the file name, so here I am giving sample.txt. Here this sample.txt is already created file, so for me it is showing displaying the content. In the case of kernel, no, it will access, okay, sample.txt, it will access by using that inode number. In another case is there, here another case, what is the another case? Here I'm newly creating one file, sample.2. This is file, so it will check if it is already available, it will display. If it is not already available, at that time it will create one new inode number. Now it is okay na? Kernel will access each files and folder by inode number. As we user, we are unable to access that inode number. It is internally created by kernel. As we user, we are accessible by only the file name or folder name. Now is it clear now? Okay. Another one question I would like to ask here. See, I am having one file called sample. See, is there? Okay, and some content is there. Hi, how are you? What my question is, I'm copying this file, the same content to another file. That another file is sample 2. So here one new file is there. My question is, I'm copying what I'm trying to do. Copy sample.txt. We will discuss this copy command in further. Now I'm for question purpose I'm saying I'm copying this sample.txt to test.txt. Test.txt. My question is, okay, my question is, here I'm copying the content of sample.txt to text.txt. Okay, here I know number is same for both files or I know number is different for both files. I'm copying the content only. But file created is new. Here the replication occurs only for the content, not for the file. So you should be clear in this point also. Here the replication occurs only for the content of the file, not for the file. Okay, so see now I am checking vi space test.txt. That is what I have created newly because I have copied the content of sample.txt to test.csv. So I'm checking. See, the content has been copied. My question is only the replication of content, not the replication of files. Here, new file called text.txt is created. So, a new inode number is created here. Is it okay now? Now I will check that too by using. So I am checking that by using ls minus li command. See, see here the last line. Test.txt is different only. Inode number is 910. See the sample.txt 920. Now is it okay na? Even though you are copying file, deleting file, anything. Okay. I think now you are clear with this inode number. Okay. Now I will move to that slide. Sorry that. Uh, y- yes, Abita, different only. Yeah. Okay, fine. Now here Linux uses hierarchy of file structure, that is upside down tree. That is top to bottom. Okay, top to bottom approach it is following. The top we are indicating by using root symbol, that is forward slash at the base of the with the root at the base of the file system and all the other directories spreading from tree. Okay, here no, these directories have some specific purpose and generally hold the same types of information for easily locating files. S- mm. See, they are given elaborately. So at the root, that is root node, we are indicating as by using a forward slash. So this is nothing but your root directory. So this is the root directory which should contain only the directories needed at the top level of the file structure. Okay, that is what are the important files, that is most needed files will be given in the topmost priority. Okay, that is root node. Second file is nothing but your bin file. So in bin file all your executable files are located. Okay, where your all your executable files will be located, it is located in bin folder. These files are available to all the user. Okay, all are executable file means nothing but what are the files you are creating. Suppose I am writing one program. Okay, suppose I am writing one program in shell scripting or any program I am writing. All the files, that programmable files are executable only. No, that programmable files we can run, right? All the runnable or executable files where it is showing, storing, it is saving in bin mode. Is it okay now? Suppose if I'm writing one program in shell, or suppose if I'm writing any one program in R or something, Python, any program, all program, what you will be saving, file name dot py, file name dot sh, something. So what these files are a runnable file. Runnable file means executable file. All your runnable files are executable files where it is available. It is available in bin. So only they are given the whole, they are available to, these are available to all the users. Okay, third point. See this, third point is dev, dev files. Dev files is nothing but your device drivers. What are devices I am connecting to it, that files that is related to device driver files, that files are available in dev folder. Okay. Fourth file is etc file. It's a supervisor directory commands, some configuration files, disk configuration files, valid user list, groups, Ethernet, host, where to send critical messages. All your super directory commands, configuration file. Configuration file means nothing but, suppose if I'm installing one software, suppose if I'm installing R, suppose I'm installing Python, I'm installing MySQL or MongoDB. Suppose what are the softwares I'm installing, along with that some configuring file will be created. No, that files, this configuration files, everything will be available in etc folder only. Wait, I will show you that also in configuration files. Wait, I will execute that also. Next one, lib files. That is, lib files is nothing but your library files. Contain some share library files, some other like kernel later files. Is it okay now? Sixth one, boot. Boot is nothing but contain files for booting your operating system. That is booting your system. Once if you are on your machine, it will take some fraction of seconds to boot. No, that is loading. So all the booting files will be available in boot folder. Okay. Home, that is next one is a home page, that is contains home directory for users and other accounts. After opening your system, you will be having that home page, right? You will be creating student login, admin login, right? That is user you are creating, student user, admin user, like that. Here you are having managing all your user accounts and other accounts in home page. Eighth one is nothing but mnt. Mnt means mounting, that is mount. Here used to mount other temporary file systems. Here suppose, which is used to mount other temporary file systems such as CD-ROM, floppy disk for CD-ROM, CD drive, floppy disk drive respectively. Suppose already I'm having my file system, default file system. Here what I'm using is swap. Suppose if I want other file systems in order to connect a device or in order to install something, we will be adding some extra files and folders. So we will be adding some packages, right? In that case, here I'm mounting, apart from what is inbuilt, I'm mounting or I'm installing something that will be available, that later kinds of information will be available in mnt folder. That too is a temporary file system like CD-ROM, floppy for CD-ROM, and floppy disk drive, etc. Okay. Next one, ninth one is a procedure, that is process, which contain all your process marked as a file by process number or other information that is dynamic to the system. So process means, suppose if I'm executing one file, is one process, right? What are the tasks we are doing? Everything the OS will contain as a process. Process 1, process 2, process 3, right? Suppose if I'm opening one game, is one process, that is user is doing one process. Suppose if I'm opening some PPT, what are the task we are doing is one of the process. Each process will be consist of some unique ID. That unique ID will be considered as PID, that is process ID. Is it okay now? All the files and folders related to process, that is accessing how many tasks has been completed, everything will be accessed in PROC folder only, that is process folder. This process concept, no, this process concept you will, is one of the topic in your syllabus. entire process, how to create PID, PPPID. Some will be discussing this entire process in upcoming classes. Some 10 to 15 commands is there. We will be discussing in later. So next one. So last file is temporary files. So temporary files hold some temporary files and contents which is used between system boots. Okay, temporary files where we are using, which is used between the system booting the systems. So it helps in system booting process, temporary files. Is it okay now? Here in coming to this point, uh, 12th one, that is SBIN. SBIN contains binary executable files which is used which is mainly for system administration. See, two things is there. One is bin is there, another one SBIN is there. Okay, in SBIN, both things, that is both bin and SBIN is containing executable files only. Okay, this normal bin is available for users. Okay, this SBIN is available mainly for administration purpose. See, don't confuse with this. Here, see, one bin is also there. Here, bin is there. Here, this SBIN is there. In both cases, you are having your executable files only. Okay, but it is available for you, available for users. It is available only for administrators. Is it okay now? Last one, kernel. So here, your kernel contains all your kernel files. Okay. Uh, mm. These can be how we can find everything. Here we can find everything by using ls command, right? We can list out what is available in which folder, what are the files and available in home page, what are the files available in root page. We can list out by using ls options. Is it okay now? In order to specify, in order to identify the inode number, you have to give ls minus I. I am giving ls minus I. Just I am giving ls minus I here. See what is it is showing. For sample 1, it is showing the inode number 448. Sample 2, it is showing inode number is 229. For sample.txt, it is showing 920 and 910 as text.txt. If you want in human readable form, you use ls minus li. It will be long list in them. Okay. Is it okay now? Along with the permission. Is it okay now?